Yes. Tell me, what is your query?
Sir, my query was limit of proportionality.
Yeah.
I mean the second part,
Uh,
second
limit
and
of
third.
limit of proportionality.
Yes, second and third paragraph. No, only second paragraph. Yeah.
This one. Can you read, please?
Yes. The higher the spring constant, the stiffer the spring. The spring constant is not the same value for different elastic objects. For a given spring and other elastic objects, the extension is directly proportional to the force applied. For example, if the force is doubled, the extension doubles. This works until the limit of proportionality is exceeded.
So you understand what does stiffer mean? Do you know?
Yes.
So it's
Hmm,
hard, right? It's hard
hmm,
to uh, extend the spring.
hmm,
If the spring constant is more, that means the spring constant, the numerical formula you have to keep in your mind when you are reading this. You have the formula F equals kx, right?
okay.
Yeah. So if it's so, your k is a spring constant F by x. This ratio, if this ratio is higher, that means you are applying too much load, but your extension is very less.
Hmm,
That time you have the greater spring constant.
okay. Hmm, hmm.
Is it clear now?
Yes, sir.
The first sentence is clear. Now the second sentence. A spring constant is not the same for different elastic objects. Even if you are taking the springs, two
Hmm,
springs of the same material, then you will get different spring constant.
hmm,
Okay, so spring constant depends exclusively for each of the material, each of the instrument or springs separately,
hmm,
individually.
hmm.
Okay,
Yes.
so it's not like same for all the like we got for density. That density of the same material is always whatever the volume, whatever the mass is. That's not
Hmm,
the matter. But for spring constant is varies. Even for the same material, you are making two springs. The spring constant is very different. It
hmm.
depends on the how how tight the spring is. Okay,
Stiff.
yeah, it's how stiff the spring is.
Hmm,
So second sentence is clear, right? And
hmm,
the third sentence is the explanation of that one, the second one. Yeah, third and fourth.
hmm, hmm.
So it's over, right?
Got it.
Yeah. Anything else from here?
No, no, sir.
Okay. Then we can go to pressure.
Hmm.
Here it is. Yeah. Please continue. Pressure.
Yeah, the first one from pressure was about the hydraulic uh, press.
Hydraulic press. Yeah. This one.
Hmm.
Where?
I think so the first para.
Can you read?
In the hydraulic press, a small force applied to a small piston in a small cylinder is transmitted through a tube
Mm-hmm. Continue.
equally against all sides of the cylinder, including the large piston, which produces a large compressive force upon a stationary anvil or base plate. A pump is used to force the liquid into the cylinder.
Okay. So which part you don't understand? The first sentence you understood. Hmm? Actually, the first sentence is a big one, right?
Hmm.
Yeah, it's almost the whole paragraph. There is also another sentence, but it's very small. So here we are giving force from here. Okay, here
Hmm.
we are pressing, and inside this tube there is liquid. Huh?
Hmm.
Inside
Sir,
this
from
tube.
where we are pressing? From that thing.
From here we are pressing. This is the handle, right?
Hmm.
Press, and here we are giving very small force, uh,
Hmm.
and this force is amplified here at the end. Okay, because your
Hmm.
surface area is bigger, you know, this principle is working here. This one. Hmm.
Hmm.
You have gone through this one, right?
Hmm.
Pressure P1 equals P2, same. So here you are getting the force, the small force in a small area. Here you are getting larger area to get this force, larger amount of force. We are using larger areas. That's it. Okay. So the
Hmm.
same way, here you see if your area is here 10 times, 10 times than this area, then your F1 is coming. F1 is coming how much? Uh,
Ten.
10 times, right? It will come 10 times this way. So this way it's working.
Okay.
Is it clear?
Sorry, I'm half clear.
This one.
No,
Okay.
no. I,
This one is clear. This part.
yes, this was clear, but
So
I did not.
this one is applied here. I'm going there. The same thing. Here you got the arrangement in different way. We are giving a push here. Okay. And there is a
Hmm.
tube. This one you see the area is very small, right? Here
Hmm.
inside this tube there is liquid. So when it's coming to this tube, this one has also area, right? This area
Hmm.
is a bigger one. This area is a bigger one, so you will get a greater force here, huh? To press
Okay.
anything. This is a dice, huh? To
Hmm.
make something. If anything is melted, then or anything you have to crush, or if you want to change the shape of any metal, you just apply force here. Huh? So
Hmm. Got it.
this way this hydraulic press is working, and there are many kinds of hydraulic press. You know that papers, newspapers. If you are getting or you are getting normal papers, lots of papers, then you can you want to transfer them from one place to another place, then you can apply this hydraulic press to compress them,
Hmm.
and making the volume smaller. Okay, so that you can carry it from one. place to another place. The cottons, the
Hmm.
cottons, you can press them and make them a small packet, lots of cotton, so that you can
Hmm.
carry them easily, right? This way, this way the hydraulic
Okay.
press is working.
Hmm.
This way the hydraulic press is working. Okay.
Hmm.
Anything else?
Yes, sir. The manometer. I wanted to know how to like do this maths of that.
Okay, the mass. There is one formula here. There, this formula. You have to use this formula.
Hmm.
This one you just remember.
Hmm.
So gas pressure. Gas pressure will be P minus P naught equals rho GH. This one.
Sir, should it be gas pressure or gauge
This
pressure?
one actually should be gas pressure. This
Okay,
is
okay. Yeah, I was thinking,
mm,
asking that.
gas pressure. So here we got uh, the main thing is here. Look, this one. This one normally, if this tube is open, then they both are equal, right? Equal height.
Hmm. Hmm.
And now the gas pressure is more. That's why it's going up this side.
Hmm.
Sometimes it happens that atmospheric pressure is more, gas
Hmm.
pressure is less. That time this side will go up. Yeah. Then
Hmm.
we can compare now how much the gas pressure is more than the atmospheric pressure. Atmospheric pressure it has a fixed value, right?
Hmm.
So that one we know. So if you get the height here, then the density of the liquid, then you can measure this pressure.
Hmm.
Okay, using this formula.
Okay, sir.
Here,
Sir, one thing. For doing maths, should the value of atmospheric pressure be 100 kilopascal or 101 kilopascal?
it depends. It depends. Like atmospheric pressure, normally we give in standard form 1 into 10 to the power 5 Pascal. Okay, this way. 1 1 into 10 to the power 5 Pascal. This way.
Hmm.
Is it clear?
Okay. Hmm. Yes. Sir, one more thing. In the manometer, if the gas pressure is less than the atmospheric pressure, should the same formula will help me to get the gas pressure? I mean, will the same formula be applicable?
Again, please repeat.
Um, if the gas pressure is less than the atmospheric pressure, then should this gas pressure formula be applicable, or
Yeah,
is it only
you
for?
will you will use it oppositely. Like P naught minus P will be that time.
Oh, okay, 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 okay. Hmm.
Opposite way because that time P naught is bigger, right?
Hmm.
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 Yeah,
And the formula will be same, rho
yeah,
gh.
similar formula. Yeah,
Okay,
this
okay,
one.
okay.
Okay, then here we have all these discussions available. Maybe you did not get time to. You just went through, right?
Yes,
Skinny.
I just went through.
Yeah, that's why all these points are mentioned here. How to do when the
Oh, okay.
atmosphere. All these points are here. Actually, here you see. It's written here.
Hmm. Hmm.
Can you read this part? This part you read
Hmm.
loudly.
Hmm.
What you asked,
If
that one is answered here. This point and
hmm.
this point. Read, then you'll
Hmm.
understand.
If the
Loudly.
gas pressure is greater than the atmospheric pressure, it will drive down the liquid level on the left side of the manometer. The pressure gas P gas will be calculated by P gas equals to atmospheric pressure plus pressure of mercury column. P gas
Mhm.
equals to P atmosphere plus H
Mhm.
rho G change in height. If the gas pressure is smaller than the atmospheric pressure, it will write down the liquid level in the right side of the manometer. The pressure of the gas P gas can be calculated by P gas equals to atmospheric pressure minus pressure of mercury column. P gas equals to P atmosphere minus rho G change in height.
So you got your answer. How to write the formula then?
Hmm.
Clear, right? And the short form is also here. Huh? Short form
Hmm.
is also here. You do
Hmm.
this way. Huh?
Hmm.
Then
Nothing else.
all are done. Huh?
Hmm.
So we are going through the worksheet now. You can go through the worksheet and check out how many are, if there is any
Yes, sir.
mistakes or not.
I could not do two questions. Small
Yeah,
question.
let me check is there or not here. Is it here?
Sir, which chapter will be after this one?
Yeah, that one we will discuss today. According to your, you know, wish, and
Wish.
according to your wish, according to your the topics you are done, those we will understand from you, right?
Hmm.
Then we will make a plan today. Hmm.
Hmm.
Then how we will proceed in future. Huh?
Hmm.
According to that plan, we will go. No problem.
Hmm.
Okay, so it was the worksheet you gave me on 24th.
Hmm.
It's a big one. That's why it's taking time, right? Mm, Let me check the mark scheme. Mm, Okay, so here it is. Can you tell me the answers? Tamjid, can you tell me the answers for MCQ part? Hello, Tamjid.
Yes, sir.
Tell me the answers. MCQ part.
Uh, 1C,
Yeah.
2B,
Yes.
3C,
Yes.
4C,
Hmm.
5D,
Dhaka.
yes,
Yes. Continue.
6 Dhaka,
Mm-hmm.
7C,
Yes.
8 Dhaka,
Hmm.
9 Dhaka,
Hmm.
10 Bangladesh,
Yes.
11 Bangladesh,
Mm-hmm.
12 Dhaka,
Yes.
13 Dhaka,
Hmm.
14A,
Hmm.
15 Bangladesh,
Hmm.
16 Bangladesh,
Hmm.
17A,
Hmm.
18C,
Yes. All are correct. Your all the MCQs are correct. Then continue.
Um, Question number 1A, shape and size.
Yeah, shape and size. Change in
Yeah,
size, change in shape, right?
yeah.
Mhm.
One is shape, two is size,
Yeah.
and then limit of proportionality. I drew it.
Wait, let me check. Here you write change in shape. Huh? Hmm.
Okay.
Change in shape, change in size. Not only shape size, huh? They say two effects. So change in shape, change in size. When you are writing size, you bracket you can give volume. Huh? Change in size, in bracket you give volume.
Hmm.
Hmm.
And uh, then B2 is the spring does not return to its original shape,
Mhm.
and then density is 31020 Pascal.
So, mm,
Um, and
the,
then I wrote because the rate at which the oil is pushed out is dependent on height or depth.
uh, because the rate at which the what you wrote,
At which the oil is pushed
which
out.
the oil, this one is oil is pushed out is dependent
It's on height
on the
or
height
depth.
or depth. Yeah. So here in both sides, you see uh, there is another thing. There is another thing you have to mention here. Like this side, uh, if it is closed, hmm,
Hmm.
the height is still same.
Hmm.
Hmm. So if it is closed, then what is the difference?
Uh, if it is closed,
The upper side is closed. You see, you read the question again.
a small crack appears in an oil tank and a stream of oil is pushed out through the crack. The oil hits the floor at P where a puddle of oil starts from. Um, Here 2.1 shows the oil tank.
They are asking about the atmospheric pressure, right? So
Hmm.
in both sides we have atmospheric pressure. Now, now in both sides the atmospheric pressure is working. Both sides means uh, the liquid's crack is this side, right?
Hmm.
And also here is the position of crack working here. So
Hmm.
we have the atmospheric pressure on both sides. Here we have liquid pressure plus atmospheric pressure, and this side we have atmospheric pressure. So if we did not have this one open, then only we have atmospheric pressure outside, not inside. So only we would get the liquid pressure that time. So the uh, flow of the liquid or flow of the oil could be affected by the atmospheric pressure. As
Hmm.
now the atmospheric pressure is working in both sides is balanced. That's why we are getting only the liquid pressure here. Are you clear?
Uh, kind of.
Yeah, you will write that as atmospheric pressure is working at both ends of the crack. Should I repeat what I said?
No, sir. I'm just trying to understand.
Hmm. Think of from the question. The worksheet is in front of you, right?
Hmm.
Go through the question. Then try to
Explain why the
yeah,
atmospheric pressure
go
does
through
not
the
affect.
question and try to understand from the description what I told.
Hmm. Hmm. Yes, sir. Sir, you said that the outside atmospheric pressure and the inside atmospheric pressure is like being cancelled out,
Yes,
right?
yes, yes, yes.
But from where is the inside atmospheric pressure coming? Like from the open end,
Mhm.
and the outside is from the atmosphere. Okay, yeah, I got it. Okay.
So you are getting something new, right?
Hmm.
That's great. So did you write it?
Yes, I'm writing it with you.
Please
Here.
write,
Hmm.
write. Otherwise you'll forget. You cut it with pencil, then write beside. You have some space here. Huh? Yeah, right.
But sir,
You
pressure is dependent on height, right?
you don't rub your one. Huh? You don't rub your one. Yeah, pressure depends. The liquid pressure depends on height. They are asking you about how the liquid pressure is independent of atmospheric pressure, and it is not affected by atmospheric pressure. Hmm.
Hmm. Sir, may you repeat the last sentence you said?
Mhm.
May you repeat the last sentence you said?
Yeah, what I said, sum up. Huh? That is the
Hmm.
atmospheric pressure is same uh, at both ends of the crack, or atmospheric pressure is working at both ends of the crack. That's the main point. Since the container is open, you can add this phrase.
Hmm. So, sir, if the container was closed, then
Then
would
it
the
is affected. Yeah, the outside, the outside of the crack, there there would be atmospheric pressure, which would make this liquid slower. Hmm. The way
like
it's coming out now, it would not
hmm.
come out that way speedy. Okay.
So the distance will be less. Like
Yeah, that time distance will be less.
okay. Hmm.
Clear?
Hmm.
Okay. Okay. Then
Then is this question and as time passes, the point where the oil hits the floor moves away from P and towards the tank. Explain why this happens.
Yeah, the one you wrote here. Hmm, this one. This one is similar to this one. The
So,
height.
sir, is my answer correct on that one?
Can you read it?
Um, it is because the height of the oil decreases since pressure is directly proportional to the height. As height decreases, the rate decreases, hence, the oil movement becomes closer to the tank.
Correct. It is correct.
Okay.
Okay, then continue.
Yes, sir, I couldn't solve this one.
This one you couldn't solve.
No, I mean A. A. No, B, sorry, B.
Hmm. B you couldn't solve. So they gave the extension load graph, right?
Hmm.
So here, how much is the extension?
Um, from 4.9 to 13.4.
Subtract, get the extension x.
Hmm. Got it.
How much?
8.5 centimeter.
8.5.
Hmm.
So where is your 8.5 here? Draw. First mark 8.5 on the graph.
Hmm.
You got it. Where it is?
Yes.
Where it is?
It's between
Can you
8 and 9.
in between 8 and 9? There is no 9 here. Where is 9?
Oh,
9
it's
you have to make.
yeah, it's below 10.
Mm, So first make 9. Then in between 9 and 10 there will be 8.5. Exactly you get it. Then
Hmm.
you draw one straight line and get the load. Tell me what is the load.
Sir, is it 3.1?
Yes.
3.1.
3.1 Newton.
Hmm.
Mm. Continue.
C, I could not solve.
See
C, I could not solve.
why. Read the question.
Student takes a second spring that is identical to the one in figure 3.1 and hangs it next to the first spring. Figure 3.3 shows a light rod uh, passing through the rings at the lower end of the springs.
Mm.
A student repeats the experiment and gradually increases the load to 9. State and explain whether the limit of proportionality is reached.
So how much each of the spring gets load? Two springs are
9.
yeah, two springs are getting 9. So
Hmm.
this load is shared. The way it is hanged from there.
Hmm.
So this 9 Newton will be shared.
Equally.
each of the spring will get 4.5.
Hmm. Hmm.
4.5 newtons. So write it in the space. You write it.
Hmm.
Each of the spring will share 4.5 newton. How you comment on it? Will it exceed or not?
1 minute. 1 minute, sir. I'm writing on it. Uh, huh. No, sir. It shouldn't. No, it will not exceed the limit of proportionality.
So write it. Write it.
Yes, I wrote it.
Now it's clear.
Hmm. Because the limit of proportionality is 7, but here each spring is receiving only 4.5.
So it's done, huh? 3 is done.
Hmm. Hmm.
Now 4. Calculate the pressure due to water. Let me check the mark screen. 3.2 into 10 to the power 5. Here is correct.
Sir, elastic limit and limit of proportionality, is it the same thing?
Same thing, same thing.
Okay.
Here you consider same thing. Okay. Now look.
Hmm.
3.2 into 10 to the 5. Then what you wrote here, can you read B1?
V1. Oh, yeah. Because the value in A doesn't contain the atmospheric pressure.
The pressure in the water at the base of the tank given. Huh?
Hmm.
Explain why the pressure in the water at the base of the tank differs from the does not contain the because that one is not taken into consideration, right? The
Hmm.
atmospheric pressure.
Hmm.
Yeah. Okay. Then B2. Let me check. You did not write the unit here.
Oh, shit. Hmm.
For this one, you'll lose 1 mark. 1.89 into 10 to the power 7. Yeah.
Sir, if they mention only calculate the pressure on the base of the tank, the atmospheric pressure should be added, right? Hmm.
Mm.
Okay.
So clear this one?
Yes.
This should be added. Yeah. It's correct. Your calculation is correct. Thank you so much. Yeah. So 10
Welcome.
minutes break. Yeah. 10
Hmm.
minutes break from now on. Then 6 p.m. we'll start the class again. Yeah. 6 to
Hmm.
6:05. Huh? Then you 6:05. Huh? 6:05 will be better. Then you gather all your information to let me know about what is done already. From there, I may ask you some questions
Hmm.
that to test you that you are really done or not.
Hmm.
Okay, thank you.
Okay, welcome, sir.